Okie dokie. So, basically, I've already done a video on all these exercises, how to make equivalent fractions of all of these. So I'll be posting that on YouTube. All of my kids that follow me on Edmodo, if you don't, I suggest you start following. I've sent the codes to your parents on Class Dojo. It's quite helpful if you go through that, because I have put on the layout for the maths during the lockdown, especially for week 1. So I've actually done the exercises number 1 for you. If you watch the video, you can actually see how I got to these numbers. Basically, you're just making the ratio of the portions bigger in these. I explained that as well. And I explained this. So instead of timesing to make it bigger, we actually divided to make it smaller. And then for exercise 2, it's basically doing comparing of fractions. So in order to compare the fractions, you need to get the denominator the same. So I've done it for you, and I said, okay, well, 12 is better to get to. So from 4 to get to 12, we times by 3. What we do to the bottom, we do to the top. So 4 times 3 gives me 12, 3 times 3 gives me 9. Is 6 twelfths or 9 twelfths bigger? 9 is bigger than 6, so actually this one would be the bigger fraction. I actually explained it as well, where the bigger one is where this part, the open part of your sign, is facing. So whatever is the biggest fraction or the biggest decimal or whatever you're trying to compare, the thing that is bigger is on the open side, the thing that is the smaller part is on the other side. So this will be called a smaller than sign, because whatever is here is smaller than that, and this is called the bigger than sign. So it's because whatever is on this side of the equation, or whatever it is, this is the biggest and it's bigger than that. This is showing that it's an equivalent fraction, so it means that it's equal to each other. So they are basically the same. They might be called something different, but they are exactly the same. And yeah, so I've done all of these so far, and I explained how to get there. And that's pretty much that. And what I've done with the ascending, so that's basically putting it in order, so ordering fractions. They've given you these, so 2/5, 3/10, and 56 over 100. So what I've done is I've given you kind of like a little step, so you make sure that they go to the same denominator. Which one can they all reach? 100. So we're actually going to keep this one exactly the same because it already has a denominator of 100. So we changed all of these. So from 10 to get to 100, we times by 10. So we have to times 3 times 10 to give me 30 over 100. The same thing here, from 5 to get to 100, we times by 20. So 2 times 20 will give me 40. And then we put them in order. So we've changed the numerator, we've made sure the denominators are the same. And then we put them in order from the biggest to, from the smallest to the biggest, because it's in ascending order. So ascending is like when an airplane goes up, it ascends, it goes up, so it's getting bigger. So that means the smallest, which is 30 parts of 100, is covered. So that means that there's less actually covered. So we've got that one, so that goes first, which would be 3/10. And then it's the 40 over 100, which is actually 2/5. And then it's the 56 over 100. I've left it as that for today, but we can quickly look at the examples. So these were the rest of the examples that we had to do. And then it says for number 3, answer true or false to the following. So what you need to do is you need to make sure that this side, a half plus 2/4 times 3/4, is smaller than that. So you need to work out what's on this side first, then work out what's on that side, and then you need to see afterwards which side is actually bigger or smaller. And then afterwards you can say true if it's exactly the same on both sides, and then false if it's not. So usually what you need to do with this, you follow the BODMAS rules, the PEMDAS, which means that you add those together because they're in the bracket first, and then you times. And then the same as this, you put all those together. Yeah, that's actually wrong. Yeah, that's wrong. But anyways, so that's going to be false. But I want you to see how it's false, and then you need to see if this side is equal to that side. So if you get the same answer on both sides, it means that it's true. If you get stuck, you can always follow the worked examples on the pages. They kind of help you a little bit. And I will be going over the rest, like adding and subtracting and all that. I'll be doing that probably either tomorrow or another day next week. But yeah, good luck, and I hope you guys are staying safe. Miss you all. And yeah, enjoy it while it lasts.